the last lesson that you guys did for the second e-learning day talked about what we call a permutation. And down here in this chart in just a moment, we'll do a quick review of what a permutation is, and then we'll compare it to what we call a combination, which is what we're looking at today. They're pretty similar, honestly, but there's one difference, okay? And that's what we'll talk about. So our objective is to find, kind of similar to permutations, to find the number of combinations of events. All right, so what you should have looked at with a permutation, this is an arrangement, oh my gosh, an arrangement, there we go, in a specific order. Keyword specific order. Let me give you a couple examples. How many ways can 6 people win first, second, and third place? So first place is definitely different than third place, right? Okay. How many ways can 4 people be voted for president and vice president? Okay. When you're finding the number of ways that a specific thing can happen. With a combination, it's not specific. It's more like how many ways can 12 people be chosen for this or not, okay? So, and what we'll do in the first few examples is look at some examples and decide whether it's a permutation or a combination, and you'll see after we go through that how it kind of works. So, like I said, a combination. I know, I don't want that, sorry. A combination is an arrangement. There we go, I can speak now. An arrangement where the order is not specific. Permutation, the order matters. Combination, the order does not matter. So, like I said, the first 4 examples here, what we're just doing is deciding whether it's a permutation or a combination. Okay? After we go through these, you guys are then usually pretty good about deciding for yourself. Okay? Number 1. In how many ways can 12 members of a jury be selected from a pool of 150? Why do you think combination? Okay. Typically for a jury, you're either on the jury or you're not. Okay? Whether you're picked first for the jury doesn't really make a difference if you're picked 7th for the jury. It's all the same. Okay? That's a combination. What about number 2? In how many ways can a president, vice president, and secretary be selected from a 12-member group? Permutation. Permutation, exactly. It's definitely different being selected for the secretary versus being selected for the president. Okay, that matters. There's a difference. Number 3, choosing 3 winners of a coloring contest, P or C?
Well, I have a question. For like the 3 winners, is it going to be first, second, third, or is it just going to be 3 winners? Yeah.
You know, that's very debatable. Is it first, second, third, or is it just 3 winners? From what it says to me, I take that as you either are a winner or you're not. So to me, that's a combination. It would have to be a little more specific, saying choosing a first, second, and third place winner for a permutation. So that's a really good question. All right, and number 4, choosing a team captain, pitcher, and shortstop for a baseball team. Permutation. It's definitely different being the shortstop than the pitcher. Okay. So permutation, the order matters. Combination, it does not. All right. So what we are going to look at now is how to find the number of combinations of a certain number of objects taken at a time. So this is denoted as n. That's the total number that you can choose from. C for combination. R for the number that you want to take. There's a shortcut on your calculator. So get your calculators out. On your calculator, your shortcut is under math. Math. And then if you hit math, the menu at the top, if you scroll all the way over, it says PRB, that means probability. And then you'll have to remind me, combination I think is number 3 and permutation is number 2. Yeah, okay. So we'll look in just a minute on how exactly we use those buttons in our calculator to calculate those, okay? So the first example, find the number of ways to rent 5 comedies from a collection of 30 at a video store. So the first thing that you want to think about is this actually a combination? Does it matter the order that I rent those 5 movies? No. Not really. You're either renting them or you're not. So we have 30 videos to choose from, and we are choosing 5. Okay? That's what I want to see as far as work. Okay? And then from there, it's a matter of using your calculator. So here's what you'll do. You'll first type in just the number 30. And then you'll go math to your probability menu. What'd I say, number 3? Yeah. I'm doing that from memory.
It says NCR.
Yeah, it says the NCR. So you'll hit that button, and then after that, you'll hit 5. And then you'll click enter. The number that you should be getting is 142,506. Okay. Next example. The manager of a factory needs 7 workers to work overtime. If there are 15 workers at a factory, in how many ways can the manager select 7 people to work overtime? So does it matter the order that he selects those people? No. No, they're either working overtime or they're not. So this is a combination. So we have 15 people to choose from. I'm choosing 7. So again, on your calculators, 15, NCR button, 7. Make sure you know how to enter this on your calculator. Yeah? Okay. What are we getting for the answer?
6,045.
Good.
I'm so sick of getting calls from banks.
All right. Last one here. Terry is buying paperback books to read while on vacation. How many different ways are there for Terry to purchase 3 novels? I'm going to do some color coding here. 3 novels and 2 nonfiction books if there are 10 novels and 6 nonfiction books to choose from. What do you guys think we're going to do here? Carly?
Oh, I was going to do 2 different types of combinations, the novels and then the nonfiction, and then just add the results together.
Close.
Close.
We're going to multiply.
Oh,
Okay? But you're right. We're going to kind of separate them up. That's why I color-coded it. So let's start with novels first. That's purple. So I have 10 novels. I'm choosing 3 of those. So go ahead and get that value. I don't have it. Oh, yes, I do. 120?
Yeah.
All right. Then we'll do the same thing for nonfiction books. So we have 6, and I'm choosing 2. That's 15. And then we are going to multiply that result together. So there are 1,800 combinations that you could choose, 3 novels from 10 and 2 nonfiction from 6. That's a lot.
Why do you multiply?
All right, last one. So here we are using combinations along with probability. In a recent survey of 30 students, 25 students favored an earlier opening time for the school cafeteria. So right away from that first sentence, what other information do we know?
You know that there's 30 students total and 25 of them.
No, what else do we know?
5 don't want to go.
Exactly. From that, what we know is that 5 do not favor it. Because maybe they like a later lunch. I don't know. All right. Find the probability that in a random sample of 8 respondents, exactly 6 favored and 2 opposed it. So we're going to kind of group up. Actually, let me erase that. We're going to kind of group up like we did 6 favored out of how many?
30.
No.
25.
25 out of the number that favored. Okay. And 2 opposed it out of how many? 5. Okay. So we're going to start with the number that favored it. So 25, and we want to choose 6 of them. Times, okay, the number that did not favor, so 5 that did not favor it, choosing 2. Now we want the probability of this. So what we need to do is divide that by the total. So the total is that we are having a total of 30 and we're choosing 8. From here, just put this on your calculator. We should be getting about 30%.